Firstly, some definitions in relation to well control. Primary well control. In drilling, this means controlling formation fluid pressure by means of the hydrostatic pressure of the drilling fluid. This might also be referred to as the primary barrier. Secondary well control. If the primary barrier fails due to an increase in formation pressure or a decrease in hydrostatic pressure, then well control equipment must be used to contain the pressures and allow primary well control to be regained. As we have discussed, the primary barrier is the column of drilling fluid in the well. Failure to maintain this barrier can result in an influx or kick. On a drilling rig, the secondary barrier refers to the well control equipment. This is made up of blowout preventers, often called the BOP stack, the blowout preventers control system, and the choke and kill manifold. On a bottom-supported rig, this equipment will be placed at or near the rig. On a floating rig, it will be located on the seabed. The importance of this equipment is paramount to prevent an influx or kick becoming a blowout, with the consequential risks to life, environment, equipment, and the reputation of our industry. While the exact nature of the equipment differs between rig types, there are many common factors. A BOP stack typically consists of an annular preventer and at least 2 or 3 ram-type blowout preventers mounted on the wellhead, which provide secondary well control in the event of a kick. The configuration of the BOP stack will depend on the type of well being drilled and the current regulations. All rigs have choke and kill lines, so that in a well-controlled situation, fluid returns can be directed to the choke manifold to allow pressure to be controlled. We'll look at this in more detail later on. The blowout preventer is designed to shut in the well to prevent a release of hazardous formation fluids at the surface and allow primary well control to be regained. The elements of a BOP stack consist of the annular preventer, which contains a large rubber or elastomeric ring which is squeezed inward to seal around the pipe, closing off the annulus. This has the ability to seal around a variety of pipe sizes. Ram-type preventers consist of 2 steel blocks that are forced together by hydraulic cylinders to seal off the wellbore either with or without pipe. There are generally 3 types: pipe, blind, and shear. Pipe rams are designed to seal around specific sizes of pipe with the aid of rubber components, closing off the wellbore. Variable bore pipe rams are designed to seal on a range of pipe sizes. Blind rams are designed to seal off the well completely when it does not contain a drill strip. Shear rams are fitted with hardened steel blades that are designed to cut through any pipe when the BOP is closed to seal the well and therefore allow the blind rams to close. Some BOPs have combined shear and blind rams, referred to as blind shear rams, designed to cut through any tubulars in the BOP and then fully seal the well. Operation of the annular and ram preventers is from the BOP control unit, where the hydraulic energy required to open and close the blowout preventers is produced and stored under pressure in accumulator bottles. Controls for this unit are usually located both on the rig floor and in a safe position away from the rig floor. Once the kick has been detected and the well safely shut in with the appropriate BOP, returns will be directed via the choke line to the choke manifold. The choke manifold consists of a range of different valves through which, in the event of a kick, pressure can be controlled, preventing further influx and allowing hazardous fluids to be disposed of safely. An important part of the well control system is the mud-gas separator. During well control operations, the gasified mud will be directed from the well, through the choke manifold and into the mud gas separator. This is a large vessel which allows mud to be returned to the mud pits and gas to be vented to the atmosphere. Valves may be installed in the drill string to prevent any formation fluids entering the pipe in the event of an influx.